going to wrap up his work on the Bass experiment for today while the team on the ground does some troubleshooting. So now we're going to head to Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is standing by to find out more about solving a fundamental astrophysics mystery.
Really hot, the Bass experiment, we're talking about something really cool today, ice cream. But it may not be the ice cream you're thinking of. This is an upcoming ISS investigation that is out of the University of Maryland. And here's the principal investigator to talk a little bit more about what this mystery and this study may unravel.
We call this experiment ice cream. We spell it as ISS cream and pronounce it as ice cream. And so, this experiment, as name indicates, we do, cosmic ray physics. Cosmic rays, you know what they are, right? These are the energetic particles from outer space. They are bombarding on us. They are providing this sample, direct sample of matter from outer space, outside solar system. And as these particles enter this atmosphere, they interact with the atmospheric nuclei and produce showers of particles, and these particles are observed on the ground with various particle detectors, experiment like OJ, high-res, fly's-eye, and so on. This technique has great advantage of very large collecting power, but the limitation is that you cannot tell what initiated these showers at the top of the atmosphere. So by flying our instrument in space, we can measure these particles before they interact with the atmosphere. So directly measuring these cosmic rays, what we call primary cosmic rays. And the ground-based measurements have already shown these particles can have energies as high as 10 to the 20 electron volt. This is humongous energy. This is beyond and above any energy that can be generated with man-made accelerators. And how these particles achieve these so high energies, in other words, how do cosmic accelerators work, is the main question. One of the big mysteries in astrophysics, and that's what we are trying to understand.
Why is ISS now an easy progression from the balloons and an ideal place to conduct this research?
Yeah, that's a good question, because cosmic ray flux decreases so rapidly as energy increases. The higher the energy you want to measure, the detector has to be larger and longer exposure time is needed. And this space station provides nearly ideal platform for this very high energy cosmic ray monitoring. So every day on station will reduce our statistical uncertainties and extend our measurements to higher energies than previously possible. Ice cream data will be much superior to any existing data at these high energies.
And so let's talk about, you're from the University of Maryland, you've gotten this research to NASA. Tell us about your student involvement and how you guys really got this going with NASA.
Students are involved in all aspects of our mission, from the development of instrument, the assembly, testing, integration, taking data up, analysis, as well as flight operation. CREAM as a balloon experiment, which was, by the way, flown in Antarctica 6 times, produced more than 10 PhD degrees by now. And at the moment, in my lab at Maryland, I have more about 15 students. CREAM provides really valuable hands-on training and experience to both graduate and undergraduate students. Beyond and above this, what can be offered from the classrooms or textbooks.
Well, I'm an astrophysicist now, and now I think I need some ice cream. But the cream study will be held over the next 3 years. So if you want to find out more about that, there will be a story coming out next week on nasa.gov/station. You can check that out. In the meantime, let's take a live look into the Payload Operations Integration Control Center. As you've mentioned this morning, they have been working on the BAS experiment, working with the crew members to get that conducted. That is what they do there in that room. And that is a backup control room. As we've mentioned, they're getting some upgrades to their full-time room. So they will be getting back in there hopefully in the next month or so, and we will be back over there. That will do it for us from the Payload Operations Integration Center at the Marshall Space Flight Center. Now back to you at Mission Control in Houston.
Thanks so much, Lori.